let's go ahead and take a look at example 3. This says the Journal of the American Medical Association reported on an experiment intended to see if the drug Prozac could be used as a treatment for the eating disorder anorexia nervosa. The subjects, women being treated for anorexia, were randomly divided into 2 groups. Of the 49 who received Prozac, 35 were deemed healthy a year later, compared to 32 of the 44 who got the placebo. We want to test an appropriate hypothesis and state our conclusion in context. Now, hopefully you are noticing that there are 2 groups again. There are those that are receiving Prozac and those who get the placebo. So those 2 groups are telling me that this should be a 2 proportion hypothesis test. Okay, we're going to start with phantoms here, so I need to list out what is happening in the population. 2 groups, so I'm going to have P1 and P2. I'm going to have P1 be the group who received Prozac, and these were the people that are healthy. So I'm going to have P1 say the percent of healthy patients using Prozac. P2 can then say the proportion or the percentage of healthy patients who get the placebo. Okay, H is my hypotheses, so my null hypothesis and alternative. My null hypothesis should start with saying that these 2 are equal. I'm assuming that the percent of healthy patients will be the same in each group. So when I subtract, I get that it's equal to 0. Okay, we're trying to see if this drug should be used as a treatment. So we're probably trying to show that the proportion of healthy patients who use Prozac is greater than just this random placebo. Again, subtracting gives me greater than 0. A stands for my assumptions and conditions, same 3 as usual. So first one is random. It does say that they are randomly divided into these groups. Next, I'm looking for my 10% condition. I definitely think the 49 patients and 44 patients is less than 10% of all patients with anorexia. Third condition, I'm checking for those 10 successes and failures in each group. So I'm going to take 49 and multiply by P and Q. They don't give it to me, they just tell me it was 35 out of 49. Oops, randomly change that to a 5. That should be 49. So 14 greater than 10. Next sample had 44 women. I don't know if they're women. They're just, yeah, they are women. Again, I'm going to find my P and Q. It just tells me 32 out of 44. 7273 should be the 32. Cutting it close, but definitely greater than 10, so we're good. Last condition, since there are two groups, I want to make sure that they are independent. I definitely do think these groups are independent. The women can't be taking or shouldn't be taking Prozac and the placebo. So samples are independent. N in Phantom stands for naming the test. Okay, this has two proportions, so it's a 2-prop z-test. T is our test statistics, so I'm listing what actually happened in the sample. So I have my 7143 minus 7273. Okay, from here I'm obtaining my p-value. Again, I need a mean and a standard deviation. My mean or expected value of the difference is what I had in my null hypothesis, which is 0. Remember, in order to find that standard deviation, I do need to find p hat pooled. So I'm going to take the number of successes in the Prozac group, which is 35, plus the number of successes in the placebo group, which is 32, divide by the total number of patients, so 49 plus 44. Okay, we're going to use that p hat pooled then to calculate our standard deviation. So we have our big old square root. I have my p hat pooled times q hat pooled, so 1 minus 2796. First, dividing by the first sample, which is 49. I'll then take the same thing, so my p hat pooled, q hat pooled, divide by my second sample, which is 44. Oh, 932. Once I have that standard deviation, I can make my normal model. Mean is still at 0. Standard deviation we just found. My test statistic this time was this negative 0.013. So that was here on the left. We are looking for greater than, right? I want more healthy patients, so I'm going to shade to the right. Hopefully you can tell just by your normal model that our p-value is going to be quite large. I do want to find a z-score. Once I have my z-score, I'm going to use my normal CDF. So we get a very large p-value, 0.5557. Now, before I go any further, I'm going to use my calculator to check, just make sure that this p-value is correct. To me, it seems really large, so I like to use my calculator to double check here. So again, I'm going to go to stat, test, to proportion, z-test. The number of successes in my first group was 35 out of 49. Next was 32 out of 44. We were looking for greater than. So it does look like they had roughly the same z-score, so their p-value is slightly off from mine, but does look pretty good there. Okay, since this p-value is greater than 0.05, we are going to fail to reject. So since 0.5557 is greater than 0.05, we fail to reject H0. Failing to reject H0 means that I think H0 is true, so I think that my assumption here in the beginning was accurate. Okay, that means that we do not have any evidence that the proportion of healthy patients using Prozac was greater than the proportion of healthy patients using the placebo. So long story short here, I don't have any evidence to show that Prozac is doing a better job than the placebo. Your wording on that last sentence there, putting that back into context, may not match mine, and that's totally fine, as long as you are drawing the same conclusion, that we don't have any evidence here to show that Prozac is doing a better job than the placebo. Okay, let's go ahead and make a confidence interval for this same data here. So I don't need to check conditions because those conditions were met above. So instead I'm just going to start plugging into my formula. So I'm going to start with finding the difference in my p-hat1 and p-hat2. Should match my test statistic up here, so I'm just going to go ahead and put that there. Next, I have my z-score times my standard deviation. Remember, no pooled for confidence intervals, just using your actual p-hats from your samples. So my z-score for 95 is 1.96. I can then plug in my proportions. So that first one was 7143 times 2857 over my first group of 49 plus my second group Okay, I'm going to start with finding this margin of error. Okay, adding and subtracting here. Gives me negative 0.1955. And 1695. Hey, again, I like to check my work, so I'm going to use my calculator real quick to verify that this interval is correct. So I'm going to stat test. I'm looking for a 2 proportion z interval. So I have my successes, and it looks like those all saved, which is nice. And I do want 95. So it looks like we did a good job there. Matches my calculator. Right, now this one is a little bit trickier because I have one that's negative and one that's positive. So this means that it could be as much as 20% lower, or it could be as much as 17% higher. So we're going to say lower for this negative and higher for the positive. So we'll start off with, I'm 95% confident that the true proportion of the first group was healthy patients using Prozac is between, here's the weird part, we're going to say it's between 19.55% lower and 16.95% higher than the true proportion of healthy patients using the placebo. So when I first write that sentence, that seems kind of weird to me. We're saying that the percent of healthy people could be lower or higher than the placebo, right? We're saying the people using Prozac, the proportion that are healthy after using Prozac, could be 20% lower or could be 17% higher than the percentage of healthy people that use the placebo. But that does match exactly what I said in my hypothesis test. In my hypothesis test, I said we don't have evidence that Prozac is any better than the placebo. So when I get down to that confidence interval, I should have one that's lower and one that's higher because I don't have evidence that Prozac is any better. Okay, you'll notice this, that any time that you fail to reject in your hypothesis test, your confidence interval should be one of these weird ones where you have one that's lower, one that's higher, which is matching your explanation in S.